My name is Ramon Pamies. I'm lecturer at the University of Cartagena. I teach material science, so I'm not a real expert in LCA. What I'm going to talk about today is more about the point of view from the materials. And also, we are going to do what Lars said before, where we are going to get ground data. We are going to work with software which is very good for teaching, but the accuracy of the database that we have is wrong. Not very robust in last words. So we are going to evaluate a window. This window, windows are glacier covered in some other transparent and translucent material, set in a frame, and we are going to evaluate just the CO2 footprint and the energy consumption. As we have been talking today, there are many impact factors, but we are going to do just a simplification with carbon footprint and the energy consumption. We are going to simplify also because we only have half an hour, simplify the case, and we are going to talk only about the glass and the frame. And we have to take into account that we have handles, hinges, we have coatings, argon filling in the window, rubber, but we are just going to omit this part and talk about the main materials that are the frame and the glass. So to use this software that you have already there, which is Granta, Granta, we open level 3. And this software is very nice for material choice. If we want to set materials, we have the material universe, and we have a lot of materials here. We have ceramics, fibers, metals, ferrous, carbon steel, low carbon steel, rod, and so on. We have around 4,000 materials in this database. In this case, we are going to use this. Okay, first of all, if you just click on one of the materials, you get the data of the material, the designation, composition, mechanical properties, and at the bottom of this, you get footprint, carbon footprint, water footprint, and processing energy, for example, and you have some of the environmental properties. And these values are the values that we are going to use for the LCA, for the assessment of the lab site. We go to Eco Audit, and now we can just wait. Are you all there? No? And now? Okay, yeah, Eco Audit. That's a code here. There. If you are here, you can go Eco Audit. And well, this is half Spanish, half English. Yeah. I'm sorry for that. Now it looks only Spanish, but it's also English. You will see later. Okay. Here we have material, manufacture, end of life, transport, use, and the report. If we go to material, then we can add here the list of materials. So finally, to do this assessment, we just need the material that we want to use, and we need to know how much material we need, and also how it's going to be manufactured. We can also evaluate the end of life. because if I pick something that we are not going to use today, here you can find how to manufacture and also the end of life. That we will talk about this later, since I see that everything is in Spanish. Okay, just the material is in English. So let's see our case. We have a glass and we have a frame. We are going to discuss two different frames. So the glass, these are the data for the glass. It's a total glass thickness 4+4 millimeters, dimensions 1.20 meter, 0.72, space between glassing 16, weight per square meter 20.1 kilometers, and it's filled with argon that we are not going to take into account in the assessment. But the problem is that here we need the mass. So first of all, with this data, which is the mass of the glass, you have to calculate it. I'm not going to do it. Actually, I haven't done it. So no, that's your own. Yes.
Yeah, 17.08 kilos.
17. Sorry, 17.
17.08.
05? 8.
Do you want the decimals?
No, I want the units.
Kilograms.
Perfect. Are you taking into account that we have two glasses?
No. Yeah, so 34.50 kilograms.
It's double placed, okay? So now we have a little bit of information. I just added the glass that we are going to use. This is a regular glass used in construction. It's glass ceramic MCR. So here we grab glass. We can say aquí window, glass, and they say glass ceramic MCR. Okay. Now we have to find this material. Where? Glass ceramic. Glass ceramic. Machinable or not machinable? Pardon? Machinable. Why? Because it's there. Machinable, but we will machine it. I mean, you cut the yes shapes. Yeah, to do this shape, you have to cut it, so it should be machinable. Here we can include how many recycled materials are we going to take into account. We just say 0 and the mass. Okay, since this is Spanish, you have to write with commas. Okay, if not, it's not going to. You have to use commas. Not listed. Primary process. Likely we only have one, that's molding. And the end of life, we are going to choose vertedero first, which is landfill. Okay? It's just to start. Are we all here? Yes, vertedero is landfill. Landfill is
The end of life, yeah.
for the end of
Indeed. Ja, men
Okay, ahora has medido el level.
tiden er ferdig. Det er igjen. Deponering. Ja, selvfølgelig. Ja, sånn, det er sånn. Ja, fancy er det ikke. Det er for noe så ganske bra. Som bare ikke så.
Are we all here? Yeah, more or less. We continue with the frame. Aluminum or plastic? We have to start with one. Aluminum. Okay. We have one frame. And okay, they are very nice. They tell us the kind of aluminum that we have, because if we go inside the program, where should we start?
Non-metals.
Metals,
Non-ferrous.
non-ferrous, aluminum.
Or aluminium.
Well, it depends on how British you are. Cathode rod. Rod, because it's a profile. So it's not being cast. Huh?
6,000. Yeah.
6,000 series. Okay, sorry, I forgot the one I chose. 66, yeah. And we use, this is 63. This is just telling us the composition of the aluminum. And then we have several options. Since this is a wrought material, a wrought aluminum, they can have different heat treatments. And for windows, they usually do just treatment called T1. Okay. So we have 14,5. And well, we have several options. We have perfilado. How do you translate perfilado? Light, profile light. We have also forge, extrusion, just to get these wires, vaporization, and this is just kind of could be metallurgy to work with the powder of the metal. What do you think that we have to use? Perfilado, extrusion, because you get the profile with an extruder. Also, we choose landfill so far. Okay, we have the materials, we have the mass, we have how to manufacture and what is going to happen with the end of life. We could take into account also the transport, not today, not at all. And the use taking into account if it's consuming energy during the use of the window. We think that a static element like a window is not going to consume energy while using, but this is tricky because if you clean it with some kind of I don't know, vaporeta with vapor or something, you are actually using energy for the maintenance of the window. But we're not taking into account this, so no transport, no usage, not today. Then we can get here a graph. Yes, with the energy and the CO2. And but I prefer to see the data with the detailed report. So here we have the energy, the CO2 footprint with the material, the manufacturing, and also the end of life. Here you have the data, material, manufacturing, and end of life, with the energy, the CO2 or the carbon footprint in megajoules, in kilograms, and also the percentage. And you have a little bit more of information if you go in the next page of the report with each part of the product that you have included. Okay. Can you explain me why, if we just say that we are not going to recycle or to do anything with the window, well, why we have here this carbon footprint with the end of life? You have to take the window to the landfill. Yeah. Okay. So I made some questions here. Can we evaluate the impact of recycling these materials? Yes. How? Ideas.
Change from landfill to some else and all that.
Okay. The glass. We can downcycle, remanufacture, reuse, or do nothing. Ninguno. There's nothing. No. Nothing. So, what? Recycle? Downcycle? Okay. And what about the frame? Downcycle, recycle, remanufacturing, reuse, or nothing?
Refabri.
You want to remanufacture?
Yes.
Okay.
With Griffith.
I would recycle, but okay, the manufacturer is fine. So we go to the report again, and then here in end of life, we have a potential end of life. Okay, this is potential because this is something that we are willing to do. Okay, and if we have chosen recycling. People expect to get the same carbon footprint and energy that they do with the material, but this is not true because recycling also is some industrial process that is consuming energy and producing CO2. Okay, but what if we are not only willing to do something, but we are actually doing something?
The material should be choose like.
We can include recycled material. Right. So, for instance, in this aluminum, if we can write a number like 25. But with some materials like aluminum, you have a typical percentage of recycled material inside. So then we go to the report And we actually see that the footprint and the carbon footprint is decreased. Not only with a potential end of life, we have decreased the values in here. Okay. Just a quick thing before you do the things. We are going to take into account the PVC, which is immersed molten. We are going to try to find PVC. Where? Polymers. Elastomer or plastic?
Plastics.
Plastics. Thermoplastic or thermoset? Thermoplastic.
Thermal.
So we found here PVC. Flexible, glass filled, unfilled. Unfilled.
That's it. Pumpkin.
Rigid molding and extrusion. Okay. And the weight is 9. And it's extruded. Okay. Extrusion. And here you have the data. Okay, so I'm done. You now have 5 or 10 minutes to answer these questions. So instead of you are not allowed to ask me anything, but you can ask anything you need. But work a little bit with the program just for 5-10 minutes and try to get these questions answered. What I like with this program, with this software, is that you can evaluate easily the different types of end of life, and you can have some numbers. But I know that the numbers are not completely accurate. But for teaching, I think it's a very useful tool. Huh?
Just downcycling.
Downcycling. Because this glass that they use actually is not completely amorphous. This glass has some crystalline parts, and when a ceramic has a crystalline part, it cannot be recycled completely. So that is why in this case we cannot. This glass is not completely recyclable.
Mm-hmm. And this is what the term of downcycle.
Yeah. Okay. So they don't have the option of complete recycling to do the complete recycle with this glass.
Okay.
This one.
Perfect.
Okay.
Thank you.
Do the S of this. Of this the amount of.
Oh yeah, how many units do you have? Because okay,
Yeah,
that
because when I'm
was
comparing, I can take.
because
Right?
if you actually write this, it is okay if you put 2 units.
Yeah.
Okay, so
Yes. And when I'm comparing this, I can take 0 on the one.
yeah.
And it's
So,
two.
so
Yeah.
actually, because I actually like to work like you're doing, like you have the 2 different frames,
Yeah.
because you can see the difference between them.
Yeah.
You don't get the data of the window, but you get the data to compare.
Yeah. And that's the question compared.
Yes.
to it.
You can work. You can do 2 projects or 1 project as far as you know what you are writing.
Would it be possible to scroll down to the questions?
Sorry. This is something that this PVC is better with this. No, with the indicators that you are using.
Okay.
Because if you have the choice to evaluate the microplastics contamination, that is something. So it's so with this and all these LCA, okay, they are very nice, but are you actually taking into account all the factors that you are
Actually, because it's maybe not with the when you are doing this.
toxicity, because with PVC, this is when they in the process to get the PVC, they have to use solvents that they are not in the normal metallurgical process in aluminum. So it's true. Yeah. La Granta, una empresa, es un spin-off de la Universidad de Oxford. Lo ha desarrollado el grupo de trabajo de Michael Ashford, que es en Europa, de los gurús de la Universidad de BIM, la verdad. Si es una validez, la que tú le preguntas.
No,
Y también tecnología buena, también pero para otra cosa, que para lo que sirve en realidad, para material choice sí que te la puedo recomendar. Si quieres hacer una comparativa de materiales, sí, porque tengo una buena base de datos. Es un handbook que tienes aquí y no necesitas de hacer a todo, y sobre todo cuando necesitas algo más, porque cuando necesitas algo más, como te sale más, te sale no solamente cómo llaman ese acero, cómo llaman ese acero en Estados Unidos, en las equivalencias con la norma americana del papá, y también te sale la serie de comercialización. Tú puedes coger ese ahora hace ahí tienes y yo no conocía hace 2 semanas. Casi todo el mundo y de una entonces lo mejor es contratar una empresa externa para que si tú tienes 100 empleados So questions, conclusions, comments. What do you think? Which is more sustainable? PVC. Are you sure? Plastic? Plastic is good?
Yeah.
With the indicator that you are using, yes. If we were talking about this before, we could have other problems if we only use carbon footprint and energy consumption, because aluminum frames, they don't have this problem with microplastics, for instance. So what I wanted to say with this case, it is that, okay, if you have these indicators, plastic is better, but you will you can make the mistake of not evaluating all the environmental impact, because, for instance, microplastics are not appearing here. Okay, we are not taking into account toxicity either. More questions, comments? No? I hope you learned something.